Hi everyone, welcome to the lecture number 7 of unit number 1 matrices. In this lecture, we'll start solving examples on non-homogeneous system. In previous lecture, we have discussed about the consistency of non-homogeneous system of linear equations, and now by using that conditions, we are going to solve the examples based on non-homogeneous system of linear equations. After the completion of examples on non-homogeneous system, we'll discuss the examples based on homogeneous system case and conditions. Also, we are going to discuss for the homogeneous system how to obtain the solution. Now, the types of examples on non-homogeneous system can be classified in two parts. First type of examples is the testing the consistency and solving the given non-homogeneous system of linear equations. So in question you will have that test the consistency, and if consistent, solve the system. Okay, in that type of problem, first we have to start the checking consistency of the system. If it comes consistent, then in that case we obtain the required solution. And the types of solutions also we have discussed. For a consistent system, we may have unique solution or infinitely many solutions depending upon the rank of the matrix A and the rank of the augmented matrix A comma B and the number of unknowns. And type 2 examples involving arbitrary constants. Okay, so whenever in examples your coefficients of x, y, z will be in the form of arbitrary constants like alpha, beta, gamma, a, b, c, k, etc. These type of notations we have for arbitrary constants in examples. Then in such a problems, you need to determine the conditions on these arbitrary constants for unique solution, for no solution, for infinitely many solutions. Okay, so this type of problems is type 2 problem in non-homogeneous system. So let us start solving examples of type 1. After that, in coming lecture we'll discuss the examples based on type 2. Okay, now in type 1 examples you will have this type of question: test the consistency and solve if consistent. Okay, so some non-homogeneous system means what? The right hand side constants, all of them should not be zero. If all the constants are the zero, then it will be a homogeneous system. If at least one constant is non-zero, it is a non-homogeneous system. So question is what? Test the consistency and solve if consistent. It means whenever the system comes consistent, then only solution exists, that we know. In that case only we need to find the solution. So the solution may be unique or infinitely many. That depends upon the rank and number of unknowns of that system. So let us start solving this first system of linear equations. Okay, so for solving in such a system of linear equations, there are various methods available. You can determine the solutions of this system on calculators also, but in this unit we are going to apply the matrix method here. Okay, using by matrix method. So what is matrix method? First you write the given system in matrix form. Okay, by matrix method, a given system in matrix form, first you need to write the matrix form of the system. In matrix form we write it as capital A x equal to b. Okay, where A is the coefficient matrix, right? Now let us write the coefficients of these equations of coefficients of x, y, z and put them row wise. So first equations coefficient 1 1 1 plus 1 plus 1 plus 1, so that will come in the first row. Second equations coefficients of x, y, z are 1 2 3, all of them are plus. Here the third equations coefficients are 1 4 9, all of them are plus. So in matrix form we have the system Ax equal to b, where the value of A is the coefficients matrix, x is what? Unknowns matrix. What are the unknowns for this system? X, y, z. Write them in a column. And the last one is the matrix of constants. What is the constants? On the right hand side, write them. First equation's constant is 3, 4 and 6. All of them are plus. Constant should appear on the right hand side. Okay, if some constant is on the left hand side, bring that here on the right hand side and then write the column matrix B. Now we have with us the matrix A, X and B. Now using this A and B, we are going to form the augmented matrix. Consider augmented matrix A comma B. We denote it by A comma B, or A colon B. Two notations are there. So this one is the easier to write. So we'll use this notation. Now how we form this matrix? First you write the matrix A, which is 1 1 1 1 2 3 and 1 4 9. Then in this matrix you write one column B, column B, which is 3 4 6, and just put one line in between for making the separation between the matrix A and matrix AB. This whole matrix is A comma B. Okay, its order is 3 by 4, and the order of the matrix A is 3 by 3. So when you want to see the matrix A, just hide this column. You will have in front of you matrix A, and if you hide this line, whatever matrix you'll have 3 by 4, that matrix is augmented matrix A comma B. Now why we have to do this? Because we are going to calculate the rank of both matrices A and matrix A comma B from the same matrix. This matrix only will give us the both ranks simultaneously. Okay, so for determining rank, because we need to compare the rank of A and rank of A comma B for deciding consistency. If they are equal, then only the system will be consistent. For determining rank, we are going to use the simplest method of calculating rank, that is the row echelon form method. Okay, so in row echelon form method, starting from the first row, we select the first pivot. Below that we make zeros. Then in the second row we select the second pivot. Below that we make 0. Like that we proceed, and finally we get a echelon form. And we are going to obtain the echelon form of this whole matrix A comma B, and automatically we'll get the echelon form of matrix A also, just by hiding this column. Okay, so let us start the transformations. So first pivot of this matrix is this entry, first row's pivot, leading coefficient. Now below this entry we have to make 0 for getting echelon form. Means this one we have to make 0. So what are the transformation that we can use here? R2 minus R1 and R3 minus R1. So let us apply them. By R2 minus R1, R3 minus R1, your matrix will be equivalent to, first row will remain as it is, which is 1 1 1 and 3. Here we have 3. Now this second and third row, this line of separation we are going to keep throughout the problem. At the end also you can draw it. Okay, I am drawing it simultaneously. After performing R2 minus R1, R3 minus R1, these two entries will become 0. Now let us calculate the remaining entries. 2 minus 1, 1, 3 minus 1, 2, 4 minus 3, 1. So 1, 2, 1. So here we'll have 1, 2, 1. Now R3 minus R1, 4 minus 1, 3, 9 minus 1, 8, 3, 8 and 6 minus 3, 3, 3, 8, 3. So we'll have here 3, 8, 3, right? Now this is the first pivot. Below that we are having 0. Now second row's leading coefficient is this, and which is appearing on the right of the first pivot. So this is the second pivot, and below that we have to make 0. Okay, so this 3 we have to make 0 for getting echelon form. So R3 we are going to change, and for making this 0 we need to multiply the second row by 3 and do the subtraction. Okay, because we never use the first row again. Whenever you want to make second rows entries below second row 0, we make use of second row. Okay, not of first row again. So after applying this transformation, we'll get our final echelon form. First row as it is, second row also as it is, only last row will change. 3 minus 3 is 0, 8 minus 3 into 2, that is 6, 8 minus 6 is plus 2, 3 minus 3 is again 0. Now put that line of separation. Now you can see that this is third row's pivot entry, this is first, second rows. All the pivot we are obtained. Means below this we don't have any row, so this will be your final echelon form of the matrix A comma B. This whole matrix is in echelon form. Okay, now from this we can compare, we can calculate the ranks. Now rank of A, here rank of A, for getting rank of A you need to hide this column, because this matrix before this line, dotted line, is your matrix A. And if you see this echelon form, all the 3 rows are non-zero rows. It means the rank of A is 3, and rank of A comma B also from this matrix we are going to obtain. For that you hide this dotted line. So after hiding this dotted line, whatever matrix 3 by 4 matrix you are having, that matrix is your augmented matrix A comma B. And if you see that this matrix is also in echelon form, The number of non-zero rows also 3 here for this matrix. Hence the rank of A comma B is also 3. This implies rank of A equal to rank of A comma B, right? So this implies given system is consistent. Now when we have this conclusion that the system is consistent, then in that case we need to calculate the solution also. And if the system is inconsistent, we can directly say here the system don't have any solution. But if the system is consistent, it means it will have some solution. Either it will be unique or infinitely many. For that we need to compare this rank with the number of unknowns. So here rank of A equal to rank of A comma B equal to 3. And 3 is the number of unknowns, which is equal to number of unknowns of the system, right? This number of unknowns, that is x, y, z. There are 3 unknowns, so the number of unknowns is also equal to the rank. Hence given system has unique solution. So this will be the conclusion, means this will be the nature of the solution. Unique solution means what? We will have the unique values of x and x, y, z. Okay. Now for determining this unique solution, what we are going to do? We are going to rewrite the equations. Rewrite equations from this echelon form. We can give this equation number 2. Rewrite equations from 2 for the final solution. So how to rewrite equation? This is the matrix A. This is the matrix B now, and just put in between matrix A. So after doing that, we'll get x plus, when you'll multiply first row to the x, y, z, we'll get x plus y plus z equal to the first constant, that is 3 here. Second equation, the 0 into x will become 0, y into 1 y, and 2 into z will become 2z. So y plus 2z equal to 1, second constant. And the final, from the last row, we'll get 2z equal to 0. So as 2z equal to 0, now how we are going to obtain the solution? Starting from the last equation. So from the last equation we'll get z as 0. This implies z is 0. So if you put z equal to 0 here, we'll get y equal to 1. Now put these values of y and z in this first equation to get the value of x, and x equal to, if you put y equal to 1, z 0, and this one you need to transfer from this side, so we'll have 3 minus 1, that is 2. So the value of x is 2. So this is the unique solution of the given system, that is the values of x, y, z. So finally you can write the solution in the matrix form also, as this implies capital X equal to, what is capital X? X, y, z equal to x is 2, y is 1, z is 0. This is the required solution of the given system. And you can cross check also your answer. When you will put x, y, z, 2, 1, 0, all the 3 equations has to be satisfied. So 2 plus 1 plus 0 equal to 3, 2 plus 2 plus 0, 4, 2 plus 2, 4, 2 plus 4 and 0, 6. So all the 3 equations are satisfied. It means we have the correct solutions with us. Okay. Now let us determine the solution of the second system. Okay. This is the second example. In matrix form, if you write the given system in matrix form, x equal to b, the matrix A will be 2 minus 3 5, 3 1 minus 1, 1 4 minus 6, which are the coefficients of these equations. X is the unknowns, x, y, z, and the b is the constants matrix on the right hand side. Now after this step, after writing these 3 matrices, consider the augmented matrix A comma B, which is the combination of A and B. In this matrix, along with this matrix, one more column we add, and we put this line of separation just for making difference between A and AB. Okay, this whole matrix is A comma B of order 3 by 4, and the matrix, if you hide this column, we'll have the matrix A with us. Okay, now we are going to apply the transformations for reducing it to echelon form and for deciding the consistency of the system. Now for reducing it to echelon form, one is available here, so that one I have brought here. So after bringing one here, the calculations becomes easier. Therefore, if it is possible to bring one here easily, then we bring that one. So I have done the interchange of first and third row. So I have obtained this matrix. After that, this is the first pivot of the first row. Below that, we are going to make 0. So for that, the transformations are R2 minus 3 times R1 and R3 minus 2 times R1. After that, we'll have this form. First row as it is 1, 4, minus 6, 1. The next two rows will become equal, that is 0, minus 11, 17, minus 1. Okay, now this is the first row's pivot and this is second row's pivot. Okay, and this pivot is on the right hand side of the previous row's pivot. Now below this pivot we have to make 0. So we are going to make R3, this entry 0 of R3 using the second row R2. So for that all the entries are equal, so simple transformation is R3 minus R2. So if you perform this transformation, this entire row will become 0 and we'll get this matrix 1, 4, minus 6, 1, 0, minus 11, 17, minus 1, and the last row 0. So this is the echelon form, as 0 rows are appearing at the bottom and the pivot of the means the leading entry of the second row is on the right of the leading entry of the first row. So clear, and these zeros we are having, so clearly this is in row echelon form. Now we are going to calculate now rank. The rank of this whole matrix is 2, which is the same as the rank of A. If you hide this column, this matrix is our A matrix, its rank is also 2. So both ranks are equal. This implies given system is consistent. Now we need to decide the nature of the solution. Okay, as the system is consistent, it will have some solution, either it will be unique one or infinitely many. So for that we need to compare this rank with the number of unknowns. So rank of A and A comma B is equal to 2, which is less than here the number of unknowns, which is 3. So whenever the rank of augmented matrix and rank of matrix A is less than the number of unknowns, in that case the given system will have infinitely many solutions. So this is the conclusion now. Now how to obtain this infinitely many solutions? If it is a unique solution, we know how to obtain. Just rewrite the equations, you will get the unique solution like previous example. Now whenever the solution comes infinitely many, we need to calculate this difference. Okay, the difference is what? N minus R. N is the number of unknowns and R is the rank of that matrix. Here we have the difference as 3 minus 2 equal to 1. So the meaning of this difference is these many unknowns means these many variables we can select as a free variable. Means out of 3 unknowns, 1 variable is free here. Means to 1 variable we can assign any random parameter. Okay, now for that purpose, first we have to rewrite the equations from this echelon form. Now I have written the equations. There are only 2 equations we'll get, not 3. Last row is 0, so only 2 equations from the first 2 non-zero rows will get as x plus 4y minus 6z equal to 1, and second row will give us minus 11y plus 17z equal to minus 1. So these are the 2 equations that we have obtained. Now for getting infinitely many solutions, this one free variable is free variable. So that variable, out of 3 any variable you can assign. So we'll usually select the last variable out of 3. So if x, y, z are the unknowns, the last variable we are going to set as free variable. Means put the value of z as t, which can be called as parameter also. Free variable means parameter also belongs to R, where t can be any real number. Okay, so z equal to t we are going to put. So if we are going to put z equal to t, all the other unknowns x and y also will appear in the form of t. So I have done the calculations from the second equation. If you put z equal to t, you will get the value of y as 1 plus 17t by 11. And if you put the value of x, z and y in the first equation, we will get the value of x as minus 15 minus times 15 plus 2t by 11. So this is your final solution. That is capital X equal to x, y, z equal to, what is the value of x that we have obtained? It is minus 15 plus 2t by 11. The value of y is 1 plus 17t by 11, and the value of z is t, where t belongs to R. So for how this is infinitely many solutions, if you put t equal to 0, t equal to 1, any real number, you will get different values of x. Means, and t are real number, t belongs to real numbers, so infinitely many real numbers we are having. So for different values of t, we'll have different solutions. There will be infinitely many solutions for this case. So in this way we can obtain the infinitely many solutions. Now a few problems of the type I'm going to give for you for practice. You just try to solve them. If you need any help, you can ask me in comment box. These are the examples for practice. These 3 solutions also I have written. So for the first system, you will get infinitely many solutions. So z will be t, y will be 1 minus 4t divided by, means 1 minus 4t whole divided by 7. X will be minus 1 minus 3t by 7. Try to get this solution. Perform the similar procedure like previous 2 examples. In the second system, you will get the answer as inconsistent. Means you will get the rank of A and rank of A comma B as different. Okay, that also you need to check. In the last, you will get the unique solution as 1 2 3. The values of x y z will be 1 2 3. So try to solve these examples. If you need any help, you can write in comment box. In the coming lecture, we are going to start the second type of problem on non-homogeneous system, that is the examples involving arbitrary constant. So that's it from this lecture. Thank you.